Hi and welcome back. I'm going to assume that you watched the previous tutorial and you are already familiar with the basics of NGUI. If that's not the case, please click the link in the top left corner and watch that video first. This tutorial is going to cover everything related to user interaction. As I mentioned in the beginning of the previous tutorial, if you were to drag in a UI element from the toolbar and then hit play, you will be able to interact with it. You will be able to drag the value, see the label change. As you hover over it, you may notice that it gets highlighted. But how does it all actually work? Well, let's start at the beginning. I'm gonna once again create a new scene. And in this scene, I'm gonna add a sprite. NGUI create sprite. So now here's a sprite in the middle of the screen, and of course if I hit play and click on it, absolutely nothing happens. There's two reasons for that. First, there is no collider on the sprite. So the first thing we need to do is right click it and attach a box collider right here. Now that it has a box collider, it will be interactable. But where do events actually come from? Well, events actually come from the camera itself. On the camera, there's a script called UI camera, which is actually poorly named. What it should have been called is an NGUI event system, because that's exactly what it does. The UI camera script sends out different events to different objects that it sees with the actual camera itself. In this case, this UI camera is what is able to draw the user interface element, and so the UI camera script attached to it is able to send events to those same objects that the camera sees. In this case, that's our sprite. So now that the sprite is actually capable of receiving events, let's add a button script to it. It is called simply button. So on this button script, there are different states. This is the color that will be assumed for the normal sprite, which is exactly what it is now. You can change it if you like. I'll keep it as white. Then there's the hover, pressed, and disabled states. You can also change the different sprites that will be chosen as well. So for example, if I wanted to change the sprite on hover and make it be something else, like for example this highlight thin here, I can do just that. So now if I hit play and hover over the element, you will notice that both the sprite changes and the color changes as well. Of course, right now, although interactable, our button doesn't really look like much of a button at this point. So let's change that. Let's make it a real button. I'm going to choose a different sprite. First, I'm actually going to ditch the hover state altogether, and I'm going to choose a different sprite for the regular state of it. I'm going to choose a window because it just happens to look nice. Now, if I hit play, it'll behave exactly as you'd expect. It just highlights and that's about it. I can click on it, but nothing happens. Next step is to add a label to this button. So I'll just right click, create label, and I'll make it a child. Child means it's going to be underneath the button. Sibling means it's going to be right next to it. So since I wanted to move along with the sprite, I'm going to make it a child. So now there's a label, and I can adjust the sprite to make it more presentable. I'm also going to choose the color for the sprite to be something slightly darker by default, just so the label is easier to see. Now if I hit play and hover over the button, it'll still behave exactly as it used to, and you will notice that the label will not intercept the events that are going to the button. That's because the label doesn't have a collider. If you were to mess it up and actually give it a collider by attach box collider, now if you hit play and hover over the button and then over the label, you will notice that it no longer gets highlighted. That's because whatever is on top, whichever widget is on top that has a collider, is the widget that is going to intercept the events. Everything behind it will not get the events, even if the events are not actually handled by any script on the object. It doesn't matter. As long as there's a collider, it will intercept the events. So let's fix the problem. Let's get rid of the collider just by removing it. In this case, I'm also going to resize the label so that it is neatly fit inside the sprite, and I'm going to give it a unified anchor. As explained in the previous tutorial, what this does is it lets the label resize based on some other target. In this case, the target is automatically chosen to be the parent, which is the sprite. So now if I was to resize the sprite, you'll notice that the label is automatically resized along with it and fits all nicely. But what if I wanted to highlight the label as well, not just the background? Well, it's actually quite simple. Since the UI button script is what highlights everything, I'm just going to add another button component here. And in this case, instead of choosing the target being the sprite, I'm going to choose the target as the label, just by drag and drop. Now that I've done that, I can still choose the colors, and if I hit play, you will notice that the label changes color as well. You can actually create all kinds of interesting effects using multiple buttons. So here I'm going to add a child to the sprite, like so, and I'm going to choose stripes instead. So for the sprite, so far we have been using two types of sprites. One was the default sprite, which was the simple one, and all it does is just draws a texture, a single quad, with the sprite stretched over it. The sliced one is what would essentially be this background here. This is a sliced sprite. If you actually go to textured here on top and turn on text wire instead, you will be able to see exactly which triangles NGUI creates in order to draw this widget. So in this case, since the sprite happens to be sliced into 9 different pieces, corners do not stretch, sides stretch only in a single dimension, and the center is the only one that actually stretches in both dimensions. This allows you to create pixel perfect looking user interfaces using very small source textures. It's good to know. But anyway, in this case, I'm going to choose a third sprite type. I'm going to choose it to be tiled. And when I do this, you'll notice that there's a bunch of quads here. Oh, I don't know if you're going to be able to see this in the video, but let me choose a different sprite. There. All it does is just it tiles the sprite. It makes it repeat over and over and over by creating different triangles, different quads, drawing the sprite and filling the area that you've defined by the dimensions of the sprite. Like so. What I want to do in this case is I want to choose stripes, I want to make them dark, and I want to position them to be exactly on top of this button right here. I'm also going to move the label to be in front. The last thing to do is to make the actual stripes far less visible than that. They gotta be a little bit more subtle. And again, this might not be something that you can see in the video due to the quality, but there isn't a whole lot I can actually do about it, except choosing a different sprite to illustrate my point. This will do. So in this case, I want this tile texture to only be visible when I'm not hovering over a sprite. I can do that by going back to the sprite itself, the original button, and choosing something else for the tween target instead of the label. Currently we have it set to the label and it's not really effective. So I'm going to choose the tiled sprite here. And you can see for the default color it assumed the current state, which is semi-invisible, and the hover, pressed, and disabled are just using default values. What I want to do is make it completely faded out for hover state and for the pressed state. Now if I actually hit play and hover over the button, you will notice that the tiled sprite completely disappears. Now if I happen to get rid of the original button component and hit play, the button will not get highlighted, but the sprite that I've tiled on top of it disappears, creating a highlighting effect. Here Here, let me duplicate this button a few more times by using Control D. Now there's 3 buttons. I hover over it, and you can actually clearly see which one is getting highlighted. Of course, if you like what you see, you can always take it and actually from the hierarchy view and drag it here to create a prefab out of it. So for example, Control, new button. I'll just call it that. So now there's a new button here, and I can just drag it to create a new instance. Of course, the next logical step is to make something happen when I click on the buttons. Here I've created 3 different buttons, red, green, and blue. And I want to change the color of this sprite right here to be a specific color. I want it to be red when I click on the red button, green when I click on the green, and so on and so forth. So what I've done here is I've created a test script, which is just a very simple script with 3 functions. Make it red, make it green, and make it blue. What I want to happen is I want the buttons to call one of these functions. This is actually really easy to do. So if you select one of the buttons, you will notice that it has the on-click notification here at the bottom of the UI buttons component. So what I want to do is I want to drag the colored sprite into the notify field, and now I have the option to select the method. For the method, I'm going to choose make it red. I'm going to do the same thing for the green and blue. Fairly straightforward. Now if I actually hit play and click on the buttons, the functions will be called and the sprite will change colors. Let's take it one step further. Let's make it so that when I hover over one of the buttons, say the middle one, the green one, I want this sprite to stretch vertically and shrink horizontally, like so. In order to make this possible, I'm going to add a tween to it. Tween width and tween height. Start with the width first. From and to values are right here. So what I want to happen is I want to change the width of it to be something narrower, like let's make it 100 for example. Now that I've done that, I can either set the value of 2 directly, or I can just right click and just choose set 2 to the current value, like so. And now 2 is matching the value of 100. In this case it's not overly time saving, but in different tweens, like positions for example, it's actually pretty useful. So now that I've done this, I'm gonna right click and assume the value of from to restore it back to the original setting. I'm gonna do the same thing with tween height. Same deal. I want it to be bigger, but in this case I'll just directly set the value of 2 to be, say, 300. Of course, now if I hit play, it will start playing automatically right away, and this is not what I want. So I'm just going to disable the components. It's as simple as that. Since they're disabled, they will not start playing right away. What I want to do instead is I want to play them when I actually click on the buttons. So I actually scratch that. I don't want it to click when I play on the buttons. I want it to play when I hover over a button. So in order to do this, I'm going to attach a new component called event trigger. Event trigger has a whole lot more notifications that I can set. The ones that I'm interested in though are on hover over and on hover out. So on hover over, I'm going to drag in my sprite, and I'm just going to choose tween width, play forward. I'm going to drag in my sprite again into the second notify field and choose tween height, play forward. For the hover out, I'm going to do the opposite. So drag in the sprite twice, choose tween with, play reverse. Tween height, play reverse. Now if I actually hit play and hover over it, you will notice that it starts playing. Hover away, it goes back to its normal size. If I don't want it to be so linear looking, I can adjust the animation curve itself. For example, let's go with this one for both of them. I'm also going to change the duration to be 0.2, again for both of them. Now if I actually hit play, you'll notice that it is not as linear looking anymore. It has a slowdown effect to it. You can even chain tweens together. So for example, if I wanted tween width to play first and then tween height to play right after it, I would simply drag the game object into the notify field of one tween. So if, for example, tween width in this case, for the method I'm going to choose tween height, play forward. So now that I have it enabled, it'll start playing right away, but when tween width will start playing, and once it finishes, it'll play method play forward on the tween height, which is the second one, which is currently disabled. Let's hit play and see what happens. First tween width, then tween height. Of course, it's probably far easier to just create animations at this point, and you can still do that. You can still use the Control-6 keyword or window animation right here, and then record your animations with the UI elements as you normally would. After all, NGUI's elements are just game objects. You can do whatever you want. And speaking of doing what you want, what if you wanted to activate these buttons by pressing keys on a keyboard like 1, 2, 3 for example? It's actually pretty easy to do with NGUI. You just attach a UI key binding script to the button that you want activated, specify which key code will activate it, in this case it's alpha 1, and then what is going to happen. In this case, press and click on the button. I've done the same thing for the green and for the blue. So now if I actually hit play and then press 1, it'll activate one button, green, activate the second one, and 3, activate the third one. This is very useful if you're doing something like a hotbar, for example, or an action bar, and you want keys like 1, 2, 3, and 4, and so on, activating specific keys. Or if you have a button in the top left corner, for example, that would open up a menu when you click on it, and you want the same thing to happen when you click escape. Well, this is how you do it, UI key binding. Same thing can be done with an input field as well, by the way. If you were to have an input field here, and you wanted it to be activatable using a key binding, attach a key binding script, specify which key code actually activates. In this case, I want it to be which is right here. And for the action, I'm actually going to select it instead. So what I want to happen is when I click or press enter, I want the input field to become selected, allowing me to type. So now if I hit play, click enter, it'll automatically select the input field, letting me type. Of course, right now if I hit enter in the input field itself, nothing happens. That's because I need to set what happens to it. I do that by selecting the input field and choosing the onSubmit notification right here. I'm going to choose the input field itself for the game object's notification, and I'm going to specify the input remove focus. Of course, if you're doing something like an input field with a player name or chat input, for example, you'll probably want something else to happen on submit, like sending this message to everyone else. But in this case, let's see, hit enter, start typing, hit enter again, the input field loses focus, hit enter, it gains focus again, and so on and so forth. You get the idea. And all done using the same UI key binding. One last thing. If you wanted to make it possible to navigate your UI using a controller or a keyboard device, you will want to use the key navigation script. Attach it to your buttons, and just attaching it is simply enough to make it possible to start navigating your user interface. But in this case, I also wanted to fine-tune it. So when I click the up button on the red, which is the top button, what I want to happen is I want to select the blue. Likewise, on a blue, if I hit down, I want it to select red. That's what the override section lets you do. It lets you specify exactly what happens without doing any logic to figure out what is underneath the button. So now if I hit play, by default red is selected, although I'm not hovering over it. If I hit down, green is selected, down, so on and so forth. Nice and straightforward. Alright, what else? Well, if you're of the curious type, you can also examine what the built-in components do. In this case, for example, progress bar changes the value of the label. And the way it does it is it has the onValueChange notification here. Remember the onClick area of the button? Well, sliders have onValueChanged instead. And in this case, it simply calls the setCurrent% value on the label. It's just a convenience method that I added at some point. And the label, that is just underneath it, this label right here. So what happens is when slider's value changes, the value of the label changes automatically. Notice that I'm not even playing right now and it's still getting called. So if at any point you want to know how things are done, just drag it into the scene and examine it. Or if you're still not sure, right-click and go to Help. Alright, well, this tutorial is now long enough. In the next tutorial, I'm going to continue on what was explained here, and I'll explain how to create scroll views, drag and drop, and a couple of other things. Thanks for watching, and again, if you want to go to the next tutorial, click here.